all running into each other, and I'm not going to have that in my class. So I'm going to go ahead and address that right now. Okay. First of all, the last day of class is April 30th. That is Friday, April 30th, not this Friday. You do not meet on Monday, Wednesday, and Friday. So that means that your last day of class is the 29th. Turn your speakers down, please, or mute. Okay? I hear myself talking. We will meet Thursday the 29th because I'm going to try to get 9.1 and 9.2 in to maybe give you another small test, which might have 10 questions on it. Okay, so another grade. 80% of your test will come from the unit test as well as the final exam. I did not push the project enough, so I'm not going to worry about that unless y'all going to cry about it. Mr. Mance, are you going to cry about the project?
No.
I didn't think so. It's stupid anyway. All right. All homework assignments is 20%. So make sure.
Can I write this down real quick?
What?
Do you mind if I write this down real quick?
No, go ahead. I've got some more things to say while you're talking. So, well, let's say that you haven't done all your homework. Get the test done. So the last test and the final exam, whenever we get through with 9.1 and 9.2, that's what the last test will be on. Okay? Now, let me ask y'all a question. If I were to give y'all, let's say I was an old-fashioned teacher, and I gave y'all, and we're in the room, and I'm working on the blackboard, and I give y'all a test, and then I grade it, and I hand it back to you. And I accidentally give everybody in the class 20 points. Is anybody going to raise their hand and go, Mr. McClure, I think you gave me an extra 20 points. I think you need to take it off.
I ain't opening my mouth. I'm going to be like.
So if the teacher gives you something, what do?
Smile and say thank you.
Say thank you.
Exactly. So if you see something on My Labs Plus and it's to your advantage, then you should take advantage of it. Not write me an email that says, I'm confused, I don't understand. Okay? Now, 3 things I want to go over. 80% test. 20% homework. Let's talk about the final exam. The final exam will cover every test that I've given you. I point and drag, no bonus questions. There are no bonus questions on the final exam. Usually, it's either 25 or 33 questions. Okay? If you want to review your test, you can do that through your grade book. You go beside the test, you click on review, and you can look over the test. You have 2 attempts, you have 2 hours, 25 questions you should be able to do in 2 hours. Okay? That's a regular test. I mean, I give you 25 questions on these tests, except some of them are bonuses. You should have the weekend to do the final exam because I'm supposed to shut off the exam on the 30th. But if you look at your final exam, you have until the 3rd. You're welcome.
Thank you.
You take the higher of the 2 attempts. The reason I give you 2 attempts is when lightning strikes your house and you have 5 dead grandmothers, you still got another attempt. And it's 2 hours. Does anybody have any questions about the last week of class?
So final exam was due on May 3rd.
That whatever my labs plus says, I don't know. And I say that with all sincerity because if I say that the test is due on the 3rd, somebody 20 minutes from now is going to ask me the same thing, Mr. Mance. So whatever my lab's math says, that's what it is. All right, now let's get to the test. Oh, I still got to make my lone wolves speech. Nobody in here is a lone wolf because you come to class. But I have students that don't come to class. They don't watch the videos. They don't communicate with me. And they come to me after grade turn in and act like there's some revelation has come upon them and they don't understand why they got zeros in their missing tests or missing homework. I already tell my department head, I remind her every final exam week, I say, remember the lone wolves. I don't respond to them. And she fusses at me. And then I say, I'm not going to respond to them. And she says, okay. So I'm just mentioning that in case one of them decide to watch, which I doubt, one of them decide to watch the video for tonight. Okay, so here we go. Here is the test. Unit 3 test. You have 3 attempts. I think I started it today or yesterday. I don't know when I started. Oh, it starts on the 29th. So it hadn't started yet. When is the 29th? That's like 9 days from now. I need to open that up earlier because we're going to finish it here in the next day or two. So I'll open that up when I need to. But I want y'all to see it because I don't want y'all spazzing. All right, preview. I'm going to do the chapter 7 test. I'm going to do the chapter 7 questions first because that's what we're on. Okay, that is chapter 6. There we go.
Is this 6 or 7?
Wait a minute.
I don't even remember.
Yeah, between. Yep, it says between. All right, so this is chapter 7. The mean gas mileage of a hybrid car is 56 miles per gallon, so that means draw the curve. 56 miles per gallon. I'm going to bring this down. Finally got them printed out, huh?
Yeah.
Well, I'm glad one person in the class did it.
Watched the video from last night too this morning.
Oh my gosh. You're the one.
I'm the
All right,
one.
56. And what's okay, so that's 53.3. So I'm going to write that up here. Mean is equal to 56. And the standard deviation is equal to 3.3. So that's going to be 59.3, 62.3. Y'all check my math, please. 65.3. Minus 3.3 is 52.7. I don't know. Somebody check me on the subtraction because I suck on that. The 49, 40, or 48.4 or 49.4. 49.4. Somebody check me. Huh?
It's 49. It's 49.
Okay, and then 49.4 minus 3.3 is 46.1.
Yes.
Yes.
Okay, so that takes care of the first sentence. So now the question, what proportion of hybrids get over 62? What proportion? Proportion is another word for percentage, area, probability. So I'm going to take my handy dandy. So I'm going to put A. What is the probability of being over 62 miles to the gallon, or whatever, miles per gallon. So I'm going to put that, that's going to be pink. So let's go to the pink marker. 62 is right here. So there's 62. And more than, that's going to be 9999. And this right here is 62. Now, if you have a older calculator, you're going to have to change 62 into a z-score. So I'm going to go up here, and I'm going to write the z-score formula down. Of course, I've written it down several times. So z is equal to x minus mu over standard deviation. And I'm going to put a little 62 right here. So you'll know I'm finding the z-score for 62. 62 minus 56 over 3.3. And z sub 62 is equal to, I'll go ahead and do that. Hold on.
1.82.
I'm sorry, what?
1.82.
Thank you. 1.82. Now, I take my handy dandy 22. If I got an older calculator to 9999. If I got a newer calculator, I punch in all of this stuff right here, and I put 62 in there. So you decide which calculator you have. I'm going to go pull up the calculator, and I'm going to do both. So the first thing I'm going to do is figure that z-score, do the z-score. So second, Lars, normal CDF, 1.82 to 9999. And 0, you can't change this if you have an older calculator. You just got parentheses. And there's that. So I'm going to take my pink marker, and I'm going to put OC for older calculator is 0.0344.
That's what I got on the old
Good
calculator.
job. And go back and do it again with a newer calculator. Realize the newer calculator carries it to 10 digits, so it will be a little bit more accurate. So all this stays 62. And then I change this to 56 and 3.3 and hit enter. 0.0345. 0.0345. Now this one is pretty close, but I've been doing these questions for homework for the last week, and I have seen some that are very, very far off. So I will be very lenient when I see a challenge question on the test, but you'll have to come see me after class, or see me after, if they're due on the 3rd, you'll have to see me, write me an email or team me, and then we can go over it. Okay? All right. So that's that question. So we go back to the question, and we do I'm going to just pick one, 0.0344. They do have a tolerance, and most of them fit, but some of them don't, and I will, if you're in the ballpark, I will give you credit. The proportion of hybrids that get 50 miles per gallon, or what?
Less.
Remember I told y'all a long time ago, it's not the math that gets you in probability and statistics. You have to what?
Read it.
Read. you have to read. So I'm going to get my handy dandy green highlighter, and I'm going to mark 50. 50 is right in here. And somebody tell me what less means. Left or right?
Left.
Left. Now, those that have an older calculator, go ahead and calculate your z-score. Those that have a newer calculator, you can go ahead and punch your numbers in. But we're going to do negative 999 to that number. So 50 minus 56 over 6.6.
No. 3.3.
50. Is it 3.3?
Yeah.
50 minus 56 divided by 3.3. I got negative 1.81.
I did too.
Shoot, I was way off on that one.
Way off
I know
by what?
why. 50 is right here. I should have marked it down here. Okay, don't worry about it. That's just me talking to myself. Okay, so if you got a newer calculator, because I think that's the one that I got pulled up. Let's see. Second large, that's the one I pulled up last. So I'm going to go ahead and type in the new calculator. Negative 9999 to 50. And everything is still in there from the last one. And by new calculator, I get 0.0345. And by an old calculator, second vars, oh crap, second vars, normal CDF, and negative 9999 to negative 1.81. And
0.0351
and 1 and 0.0351.
Yeah.
Now, what did I type in last time? The old calculator or the new? I typed in the old calculator. This time I'm going to type in the new calculator, which is 0345. 0345. All right, next. What are between 58 and 61? Well, 58 is right here. Let's see, 56, 58 should be probably right in here. And 61 is right about here. Between means between. $58 to $61. So if you've got a new calculator, this will save you a little bit of time. If you got an old calculator, go ahead and change 58 and 61 into z-scores. 58 minus 56 over 3.3. 61 minus 56
I'm in class. I cannot talk.
over 3.3. So if somebody could actually calculate those for me, I'm not going to do that with my mouse. That just takes too long. So somebody give me the left one. What is 58 minus 56 divided by 3.3? It looks like it's going to be around 0.5 or 0.6 something. What is it?
0.6. 0.6060.
No, even. I need to know precisely. Round to the second digit.
0.61.
0.61. All right, somebody give me 61 minus 56 divided by 3.3 and round to the hundredth, the second digit. Looks like that one's going to be 1.6 or 1.7.
1.5.
Okay. Everybody got 1.5? I need another digit.
1.51.
Okay. Okay, now, according to your calculator, whichever one you have, you're going to go, if you have an older calculator, from 0.61 to 1.51. If you have a new calculator, you're going to do 58 to 61. I'm going to do the new calculator because of time. So here we go. Second, VARS, normal CDF. I'm going to go from 58 to 61. The mean of 56 and a standard deviation of 3.3. And everybody's calculator should be within 3/10,000ths of this. 0.2074. 0.2074.
I got 0.205, but
Yeah, that's 0.2075, 0.2073, all the way up 3 places, between 0.2077 and between 0.2071. That is good enough for government work. All right, so that's 0.2071 or 0.2074. And what does the last one say? The probability that a randomly selected hybrid gets less than 46 miles per gallon. So I'm going to do that in what other color?
-99999.
Yep, to whatever that z-score is, but I got to find a different color. I guess I'll do orange. Orange, and that's going to be 46. 46 is right here. So this is going to be a very small, -99999. And I'm going to do it with the new calculator, and then you can check y'all's answers with it. Second, VARS, normal CDF. And I'm going to go from -9999 and 46. How do I know it's going to be very small? Because I look at my empirical rule, and it tells me what? It's going to be very small.
Percentage, yeah.
So that's going to be percent, paste. It's going to be less, I'd say 0.12 or 0.13.
I got
It ain't even that.
I got 0.0012.
0012. What'd you get? Good.
0.0012.
And let's turn it back to the question. 0.0012. Let's hit check answer. And we got them all right. Okay, next question. That's a bonus question. That's a bonus question.
This is not the final exam. This is just
no,
unit
this
3,
is our
correct?
unit. It says right there, unit 3 test.
I'm just making sure.
That's NPX. That's chapter 6.
I don't remember how to do that.
This is chapter 6. I'm more worried about chapter 7 because that's the one we just finished. Or we're finishing. And I want everybody to see that the test is not the Antichrist. All right, determine whether the following graph can represent a normal density. It looks like to me it's normal.
Normal bell curve.
Yep, that's a normal, yep. Next. Okay, y'all know the 2 tests for chapter 6. All of them have to equal what? 1. And they have to be between 0 and 1.
0 and 1.
right there. Okay, because they can equal 0 and they can equal 1. So you have to do the equal signs. That's chapter 6, but that's a short and sweet question. NPX, we'll get to that when we've got time. Come on, where's chapter 7? I know we got some more. Okay, there's uniform distribution, and they do give you height. And we did 2 or 3 of these in class. Graph to the right, and I think we did one like this one. The graph to the right is a uniform probability with a height of 1/30 and a base of 30. Find the probability that the friend is between 25 and 30 minutes late. So I'm going to go ahead and draw mine while you were drawing yours. And you just sketch this one. So we've got a rectangle with a height equal to 1/30 and a base from 0 to 30. And I'm going to graduate my bottom so everybody can read it. There's 15 in the middle, 5, 10, 20, 25. And they want to know the probability of being between 25 and what? 30 minutes late. So I take my handy dandy orange marker and what side am I going to shade?
The right.
Between, in the middle.
The right side. Because it's, yeah, you're right, between 25 and 30 minutes. Or you could say the right side of the orange line. Either one of those answers is correct. So somebody tell me what the probability of being between 25 and 30 minutes late is going to equal. Base, what's the base?
25.
What's the base?
Sorry, 25.
What's the base?
You don't 5. It's 5.
5. And the height is 1/30. And that's 5/30, which is 1/6, I think, which is 0.17 or 0.1667. So there is a 16 or a 17% chance that this person is going to show up 25 to 30 minutes late. B, let's go to B. B, there is a 10%, no, there's not 10%. B is equal to 0.1000. Since that's a percent, I got to change that to an area. Okay, so there is a, within how many minutes? 10% chance. There is a 10% chance. Okay, so we've got an area of 0.1000. So you're going to do this. You're just going to do this on paper. You're not going to draw a picture of this. I can't find the dadgum there. So 0.1000 is equal to base times 1/30. Area equals base times height. Divide by 1/30 to get rid of the 1/30. If you do it on one side, you got to do it on the other. Cancels. B, or the base, is equal to, I'll do it, 0.1000 divided by, parentheses, 1
3.
divided by 30. Enter. Good job. So the person is going to show 3 minutes late, which will be 10:03. They're going to show up by 10:03. But the answer is 3. So you go to the handy dandy question and you type in .1667, and you type in 3 minutes, and you hit round to 3 decimal places. Read the directions, because 1 minute they ask for 3, and the next minute they ask for 4.
So is it
So-
0.3000?
Huh? 0.167. They asked for 3 decimal places. 0.167.
I
I
okay.
put 1667.
Yeah, I did too.
Next question. Next question. In sports betting, let's see. Okay, that's chapter 6, I think. Yeah, that's chapter 6. Yeah, probability. 9 or more points. Wait a minute. In sports betting, sports books establish winning margins for a team that's favored. An individual can place a wager on the game and win if the team bets upon after. For example, if a team is favored by 5 points, wins the game by 7 points, then a bet on the team is a winning bet. However, if team A wins the game by only 3 points, yeah. Okay, here we go. Suppose that in games, the margin of victory for the favored team relative to the spread is approximately what?
Normally distributed with a mean of 0 and a standard deviation of 11.5.
Which means draw the damn curve. So I'm going to go draw my curve. This time they don't put that in the beginning of the sentence. They put it at the what? At the end. So mean is equal to 0, and standard deviation is equal to 11.5. And I'm not going to look at anything else. Right now, I'm going to draw my curve. So 0, 11.5, 22, what would that be? 22 be 23, wouldn't it? 23 plus 11.5 is 34.5. Somebody check my math. 0 minus 11.5 is negative 11.5. Negative 23, I assume.
Yep.
And negative 34.5. And that one's ready for the trash can. All right, now we're ready to see what the question's asking. What is the probability that the favored team wins by 9 or what?
More.
More means right. 9 or more. So we're going back. 9. Where is 9? 9 is right. So A, 9 or more. So that means 9 is, there's 11. Half of 11 is 6.75 or 5.75. So 5.75 is in the middle. So half of 5 is 2.5. So that'd be about 7. About 9 is right here. So I'm going to put it about right there. So we're going to be dealing with 9999, not negative, but positive, because they want to know more. Now, you're going to have to use your new calculator, punch in the numbers, or change 9 into a z-score. So that'd be 9 minus 0 over 11.5. And that's 9 over 11.5. Somebody give me that z-score to 2 decimal points, please. It's not going to be 1. It's going to be like 0.9 or 0.8.
0.78.
That's good. 0.78. So if you got an older calculator, you're going to do negative 0.78 to 9999. If you have a newer calculator, we're going to do it right now. Second, bars, normal CDF, 9
Point.
to 9999, 0, and 11.5. And if you got a newer calculator, you're going to get 0.2169. What did you get, Miss Kidd?
0.2177.
Okay, see, there's one. You could say 2170 versus 217 what? 77. So you see, right there is a good example. Now, if you wrote either one of those and you got it wrong, I would give you the points because you see that's a little bit more than 2 or 3 hundredths. I meant 2 or 3 10,000ths. That's 7 10,000ths. So that's a little bit too much, but both of them are correct.
What number was this on the test?
Oh, it's going to be different on your test, but it was number 23.
23.
All right, you do B and C, or to go ahead and work on B. 9 or more, it says round to 4. So I'm going to use the older calculator, and let's see if we get it right. 0.2177. Okay, what is the probability that the favored team loses by 2 or more points relative to the spread? Okay, 2 or more. Well, that'd be right beside the 0, would it not? Be right beside the 0.
It'll go to the right.
Yep. So it's going to be more than 21%, what we just did. So I'm going to do that in blue. 2 or more points would be right here. So I'm going to do that in blue. And it'd be close to 50%. So, wait a minute. Wait a minute. Loses would be negative.
Is it going to be negative or is it going to be positive?
Yeah, loses is negative. I didn't see that till just now. So that would be on the left side. Sorry about that.
That's fine.
So that's negative 2. And you're going to have to change that to a z-score. And that's going to be negative 9999. Because let me ask you a question. If you lose by 2 points and you lose by 30 points, 30 is greater than what? 2, because you lost by more points. Okay, so I just want you to realize that. We're not talking about bank accounts. We're talking about points. Okay, so it's different with points. So I'm going to show you what I've got here. Just ignore the right side because this is what we're finding. We're finding this side. So it's going to be from negative 9999 to negative 2. It should be. So
I thought we had to find the z-score.
For an older calculator, yes. I'm going to use the newer calculator.
Okay, that's okay.
Second bars, normal CDF, negative 9999, and you can check your score with mine, negative 2, and paste.
0.43.
Oh, 0.4310.
Yeah, that's what I was going to say.
0.4310. And that's that one, 0.4310. Explain the meaning of margin of victory relative to the spread has a mean of 0 points. Okay, well, what does 0 points mean? That means that they're tied. Does everybody understand that? The spread means how much one team wins over the other. So 0 means what? That there's no spread.
No
So
spread.
you got to have a difference in the teams. If the Green Bay Packers play the Tampa Bay Buccaneers, one of the teams has to what? One of the teams, by the time the game is over, one of the teams has to what?
Lose.
Lose, and one team has to win.
Win.
And that's the spread. Okay? Now, if Tampa Bay is favored to win, then that means that Green Bay has a spread of 4 points, meaning that if to cover the bet, Tampa Bay has to win by 4 or more points. So that's what that means. So yes, the fact that 0 means that the outcome of the game is typically close to what predicted by the spread. Yes, the fact that the mean is 0 means that the average outcome of a game is a tie. That could be it, but this is a Philadelphia lawyer question. Hold on. No, the fact that mean is equal to 0 means that the average outcome of a game is a tie. So the no and the yes, let's see what it's asking again. It's asking, explain the meaning of margin of victory relative to sport spread. Has a mean of 0. Does this imply that the spreads are accurate? I would say no, but I miss these Philadelphia lawyer questions all the time. So, and I missed that one, so it must be yes. No. C. Oh, it must be A then. Write that one down. Write A down. Yes, the fact that 0 means that the solution of the game is typically close to what is predicted by the spread. So make sure you write that down because that's the answer to that test question. We got the math right. Hurry up and write it down because I want to get to any other Chapter 7 questions.
I'm good.
Tell me when y'all got it. Y'all got it?
I'm good.
All right, next question. Okay, we've done this one in class. The mean incubation time for a type of fertilized egg has a mean of 23 and a standard deviation of 2 to draw the damn curve.
Yeah, and this
That's
is
what
one
it
that
says
confuses
right
the
there.
shit out of me, and I can't even do it on homework.
So we got a mean of 23 and a standard deviation of 2. So that's 25, 27, 29, 21, 19, and 17. And somebody please check my math. I'll show you what mine looks like. There it is. So check my math. 23 plus 2 is 25, 27, 29. 23 minus 2 is 21, 19, 20, 21, 19, 17. All right, so there's your picture. Now let's see what the question asked. Draw a normal model and describe egg incubation times of these fertilized eggs. Okay, so choose. So I don't like when they do this right here because this takes time away from the student. Okay, so 17 in the middle. Is that right or wrong?
I can't read.
Wrong.
No, it's
Wrong.
wrong.
So that's not it. Okay, 23 in the middle, 25, 27, 29, 21, 19, 17.
right.
That looks good. Let's see what the other two look like. 29, nope. 23, 27, nope. So it can only be what?
B.
It can only be Bravo. Okay, now let's see what it says. Find and interpret the probability that a randomly selected fertilized egg hatches in less than 19 days. So I take my handy dandy, I'm going to put in orange, probability of less than 19 days. And y'all know how to do this. We've been doing it the whole class. 19 is right here. So that'd be negative 9999. And change 19, that's 19 minus 23, divided by 2. Somebody give me that z-score, 2 digits, please.
-2.
-2. So if you got an older calculator, you're going to go from negative 9999 to -2. If you got a newer calculator, you're going to go from negative 9999 to 19 with a mean of 23 and a standard deviation of 2. What'd you get, Miss Kidd?
0.0228.
So that's your probability. And 0.0228. Next question. If you multiply that by 100, what do you come up with? Move the decimal 2 places to the right.
2.28.
2.28. And if that's people, that's going to be 2. If it's days, it's going to be 2. I don't know if they want you, if in every group of 100 fertilized eggs, 2 eggs would be expected. 2 eggs would be expected. If 100 fertilized eggs were randomly selected, 2.28 of them would be expected to hatch in less than. I like that one. I like A and I like B. Why don't I like B? Why don't I C? Why don't I like B?
It says exactly.
It says what?
Exactly.
It says exactly.
It says exactly on, right here, on day. In other words, bam, right there on day 19, they're supposed to be fertilized. And of course, we don't do that in math. So which one is it? Let's see what the difference. Okay, if a group of, I like, what did I tell you about statistics? You like to sound what? Fancy. So what sounds fancier? In every group of 100 fertilized eggs, or in 100 fertilized eggs were randomly selected.
We're randomly selected.
There you go. 2 of them, and I don't know, they want to round to the nearest integer, 2 of them would be expected to hatch. All right, y'all do this one. Find the probability that a randomly selected fertilized egg takes over 27. Okay, this same, you don't have to do anything. Just change it to a positive and go from that number to what? 9999. Because why? They are symmetrical. Look here. 27 is positive 2, so they're symmetrical. So it's going to be 0.0228 again. I don't know why they would give you 2 of the same. That's a little bit redundant.
0.4910.
Should be the same. 2 to infinity. Second, vars. Normal CDF from 2 to 9999. And means 0 and 1. What'd you get, Miss Kidd?
Well, I was doing the 0.228 to 999. That's not right, apparently. 2 to 9999 close .227,
Yep.
0.226.
0.0228. Yeah, that's fine.
Yeah, that's what I was trying to spit out. Yeah.
Okay, so let's type that in, and it's the same answer. The probability is 0.0228. Maybe I should take this one off because it's
God dang.
the same thing. Two of them would be expected. It's the same question.
Please take that off the test.
You want that one because that's the easy points. That's easy points.
No,
Just
it's not
opposite.
for me. Not for me, it's not.
D. Find and interpret the probability that randomly select between 21 and 23 days. All right, so I'm going to use a different color now. 21 and 23 days. 21 and 23 days. Now, somebody tell me what they think the answer is going to be near. Come on now. Everybody should be saying that out loud.
22.
0.3400 because your empirical rule says that it's 34%. 0.3400. So let's go. So y'all go ahead and change. That'd be 21 minus 23 divided by what? 2? Is it 2? Yeah. And that's that z-score. And then this z-score, we don't have to do it, but it's going to be 0. And that's going to be -1. So 23 minus 23 over 2 is 0. And this should be -1. But y'all check my math.
I got it right.
And y'all do it on y'all's calculator from -1 to 0 or from 21 to 23. But by the empirical rule, you're going to be around 0.3400.
Yeah,
What does it come out to be?
341.
Give it to me one more time. 0.34 what?
13.
0.3413. So I'm going to go type that one in. 0.3413. If 100 fertilized eggs were randomly selected, you know it's going to be between, expected to hatch between, this says on, and that's not it. And this doesn't sound fancy enough. It don't have randomly, so you know it's this one. And what is 34.13 close to? 34. And would it be unusual for an egg to hatch in less than 17? So let's go to 17. Where is 17 on our picture? 17 is right here. Somebody answer that question. You don't even have to calculate it. Somebody answered. Is it unusual?
Yes.
Yes.
It is unusual because it's in those tails that we said back from chapter 1 or 3. It's in those tails, so it should be unusual. So you shouldn't have to do any math on that one. The probability of an egg hatching. Now you might have to find the. So go ahead and do -9999. 17 minus 23. Isn't that -2? Somebody do that. So they might ask for that. Yeah, I got to round it to 4 decimal places. Somebody do from -9999 to -2. What do you get? Give me 4 digits. I'll do it. Second, enter. 9999 to what? Comma, -2, right? That's what I said, I think. Comma, -2.
0.0278.
Now you do it.
I'm exhausted. I'm
0.02.
sorry.
0.0228.
I'm trying not to fall asleep in class.
I didn't hear you. What?
Then I'm exhausted. I'm trying not to fall asleep in class.
No, it's -3. I'm sorry. -3. I did it wrong. It's at the third standard deviation. My bad. I didn't do the math in my head. I'm sorry. It's still less than a nickel, so it's unusual, but you got to do the numbers because it's wanting the number. So it's -3. Somebody take 17 away from 23 and divide by 2. You should get -3. I'm sorry. Second, enter. That's supposed to be -3, not -2.
I vote we take this question off and put one of those ones that they say the area between.
0. I'm not taking it off. 0.0013. That's the answer. 0.0013. I'm trying to get done with this for y'all. 0.0013. So it is unusual because 0.0013 is less than a nickel. And we got that one 100% right.
So what did we do wrong, or what did you do wrong?
I just told you. Take 17 with your calculator. Take 17 minus 23 and divide by 2.
5.5.
What?
5.5. 17 minus 23 divided by 2 on -3. Whatever.
You're
I'm
tired.
flunking anyways. It don't matter.
Yeah, go ahead and say that. That's good. That's a good
This
thing to
question I will. This
say.
question I
Yeah,
will.
you're gonna get all of it wrong.
Probably.
All right, next, let me do the last one on chapter 7, and that'll leave chapter 6 for next time. So next one, let's see, am I going right or left? I think I'm going right. 25. All right. Standard mu is equal to 63, and the standard deviation is 10. So mu is equal to 63 and a standard deviation of 10. So 63 in the middle, 73, 83, 93, 53, 43, and 33. I think I did the math right on that one. I'm going to write down what they say so I can transfer it to my, and they want to know the probability of being between 56 and 66. So I want y'all to do it. There it is right there. Let's see, halfway between, that'd be 48 right there. We need what? 56. So, I'm sorry, 56. That'd be 58. So 56 would be right here. And 66, well, 63 to 73, that'd be 68 right there. So 66 would be right here. I got this, y'all. I don't know. What'd y'all get? Know what y'all's looks like? 56 and 66. 56 minus 63 over 10. And 66 minus 63 over 10. 3 over 10 is 0.3, so that one is 0.3. I can do that one in my head.
The other one's negative 0.7.
Thank you. All right, so if you got an older calculator, negative 0.7 to 0.3. If you got a newer calculator,
0.3759.
I'm sorry, what?
0.3759.
Wow, somebody did that real quick.
This somebody's been up since
I thought you
1:30.
couldn't do it. I thought you couldn't do it.
I didn't go to bed till 1:30 this morning. I had to take my dog to the emergency vet clinic.
All right, I hate
I'm
that.
tired.
Not a dog person, but I hate that for you. All right,
Yeah.
so which one is between 56 and 66? It's not Charlie or Delta.
It's B, Ben.
Well, you got to see which one's closer. I believe it's B. No, it's C. I mean A. Because look at my picture. Which one is closer to the center? 66 or 56?
66.
And that's why it's closer.
Okay.
I mean, that's why it should be A. Next, the probability round to 4 decimal places is 0.3759. Good job. Now, we have just went over all the Chapter 7 questions. Now, let's see how many we had so y'all can, I got them right here. 1, 2, 3, 4, 5 questions. Now, 2 or 3 of those questions had several parts. I know that. But I want you to realize that you don't stress over Chapter 7 because you're only talking about 5 questions with 2 or 3 having parts. Okay? All right, let's call it a night and go over Chapter 6 Thursday out of the review section. And any homework
have you opened the test?
I'm not going to open the test yet, no.
Okay.
I'll probably open it Thursday. All right, y'all get out of here and rest. Have a good night.
Bye. Thank you.
Bye-bye. And hopefully the people that leave their computer on, maybe y'all can leave for me so I don't have to throw you out. I appreciate it.